Okay, question 11, the final question, 7 parts, 13 marks. So, the intensity of the sun's radiation, Y, watts per square metre, and average distance from the sun, X astronomical units, are shown in figure 1 for Mercury and Jupiter. We're told the intensity is proportional to a power of the distance x. Part 1 wants us to write down an equation for y in terms of x and two constants. Okay, so first of all then, if y is proportional to some power of x, we say y is proportional to x to the power of, let's say, n. Now that describes the proportion. We need a formula, so we're going to use y is k times x to the power of n. Okay, part 2 wants us to show that the equation can be written as log y is a add b log x. Okay. So, if we know that y is k x to the power of n, we need to turn y into log y. So we're going to take logs of both sides. So log y is log of kx to the power of n. Now using the laws of logs, on the right we can say log y is log k add log x to the power n, and then by the laws of logs we get log k add n log x. So that is in the form that they want it. Log k is just a constant, which we could call a, and then we got n log x, so that we can think of as b log x. Cool. Part 3 in the printed answer booklet, complete the table for log x and log y to 4 sig figs. So you can get the answer booklet from the website. If I remember, I'll link it down below. It's not very exciting. This is our table. So all that we need to do is log each of these numbers and put them in their corresponding place. So for Mercury, log x will be minus 1.179, and for Jupiter we will get 1.599. Log y for Mercury is 9.575. and for Jupiter 4.022. Cool. Okay, then part 4 wants us to use the values in the table to work out the values of A and B. So, remember from this part, we've shown that log y is some constant log k, which we can call A, add n log x, we can call n b, no props. So, if we have y log y is A add b log x, if we compare that to y equals mx plus c, b is the gradient and A is the y-intercept. So, we need to find B first of all. So, gradient is difference in y over difference in x. Here, that's difference in log y over difference in log x. So, that's going to give us, let's go 9.575 minus 4.022 over minus 1.179 minus 1.599, and that is going to give us minus 1.999. Cool. Okay, so now then we know that log y can be written as A minus 1.999 log x. So, to now find the value of A, we're going to substitute in a pair of log x and log y values. So, let's use the top ones. So we know that when log x is minus 1.179, log y is 9.535. So, we know then that 9.575 is equal to A minus 1.999 times minus 1.179. So that gives us 9.575 is equal to A and 2.357. So take that away and we get A is 7.218. Cool. So we can say then that log of y is equal to 7.218 minus 1.999 log x. Cool. Okay, then for part 5, hence rewrite your equation from part 1 for y in terms of x using suitable numerical values for the constants. So, remember our equation from back in the old days was this guy here. Y is kx to the power of n. So, what we need to do is, we know the value of n is minus 1.999. What we need to do is find the value of k. So, again, remember that we've said that a is log k. Now, we know that a is 7.218. So that means log k is 7.218. So k is e to the 7.218, which, if we go to the nearest whole number, gives us k is 1,364. Now, because n is minus 1.999, I think we can happily round that to minus 2. So we can say y is 1,364x to the minus 2. Cool. Part 6 wants us to sketch the graph of the equation found in part 5. Okay, so essentially we're just sketching y is 1 over x squared. So, all of this is going to look like is something like that, where I guess we should label the axes. So, y equals 1 over x squared, or 1,364 over x squared is never going to be equal to 0, so it's never going to touch the x-axis, and it's also never going to touch the y-axis. So the axes are asymptotes. So that's a fine sketch. Okay, then the final part, we are told that Earth is 1 astronomical unit from the Sun. Find the intensity of the Sun's radiation. Okay, so remember x was the astronomical units, y is watts per square meter. So, all that we're doing is substituting x equals 1 into our equation for y. So when x is 1, y is 1,364 watts per meter squared. Cool. And with that, guys, paper 1 is done. I'm going to start on paper 2 right now. Hope this has been helpful. Don't forget, give us a thumbs up, get subscribed, good luck in your exams, take care, take it easy.